The chair you're sitting on is an illusion. It feels solid, but it's 99.999% empty space, a frantic cloud of particles that only coalesces into a chair because you are looking at it. This isn't philosophy. This is the conclusion of the most tested, most successful theory in the history of science. You're about to see how the bedrock of physics points to a reality so strange it was first described by mystics thousands of years ago. And understanding this shifts your role from a passenger in the universe to the very thing that makes it real. Let's begin in a world that makes sense, the world of classical physics. If you roll a bowling ball down an alley, it behaves predictably. It follows a single clear path. It's a solid object in a definite place, moving at a definite speed. This is how we experience reality every single day. The problem is, this reality is a clever forgery. At the smallest scales, the universe operates by a completely different set of rules. Rules that are deeply unsettling. Down there, in the quantum realm, things are different. An electron isn't a tiny bowling ball. It's a smear of possibilities. Until it's measured, it has no definite position. It exists as a probability wave, a cloud of potential locations. It is everywhere and nowhere at once. This isn't a metaphor. It's the mathematical reality. So physicists designed an experiment to test this ghostly nature. It's called the double-slit experiment, and it's the rabbit hole reality disappears into. Imagine a wall with two vertical slits in it. Behind that wall is a screen, like a photographic plate, that records where things hit. Now, imagine firing tiny particles, like grains of sand, at that wall. Some get blocked. Some go through the left slit, making a mark on the screen behind it. Some go through the right slit, making another mark. After firing thousands of them, you'd expect to see two distinct lines on the screen. Simple enough. And when physicists did this with electrons, that's what they expected too. They fired them one at a time, so slowly that one electron would hit the screen before the next one was even fired. But they got something else entirely, a pattern of many lines, an interference pattern. This is the signature of a wave. It happens when a wave passes through both slits at once, and the two resulting waves interfere with each other, creating peaks and troughs. The only way to get this pattern is if each individual electron went through both slits simultaneously. The single electron, a particle, behaved like a wave. It interfered with itself. It explored every possible path and only then decided where to land. It existed as pure potential until the moment of impact. This discovery is strange enough to build a new physics on. But it's what they did next that tears a hole in our understanding of reality. The scientists were baffled. They wanted to know how this was possible. They wanted to see the electron go through both slits at once. So they set up a detector, a tiny measuring device right by the slits that would register which path the electron took. A simple act of observation, a single bit of information. Was it the left slit or the right one? And the moment they turned on the detector, the interference pattern vanished, gone. In its place were two solid lines, exactly what you'd expect from grains of sand. The act of watching forced the electron to choose. It collapsed from a wave of potential into a single definite particle with a single definite path. The universe behaved differently because it was being observed. Let that sink in. The outcome of a physical event depended on whether or not it was being watched. This is the observer effect, and it forces a terrifying question. What counts as an observer? Does it have to be a human eye? A conscious mind? This is where the debate splits physics into two camps. The mainstream, more conservative view offers a straightforward explanation. It's about information. The observer can be anything that records which path information. A photon, a microscopic detector, even a single molecule of air bouncing off the electron is enough. Any interaction that leaves a trace, that extracts information from the system, collapses the wave of possibilities into one reality. In this view, consciousness is irrelevant. The universe is a vast, interconnected machine, and observation is just one gear turning another. A critic of the consciousness idea would rightly point out that we have zero evidence of consciousness being necessary for this to happen. Any physical interaction will do, and for many scientists, that's where the story ends. It's a mechanical process, tidy, impersonal, but the very founders of quantum mechanics were deeply disturbed by this. They couldn't shake a deeper feeling. Max Planck, the father of quantum theory, stated it bluntly. I regard consciousness as fundamental. I regard matter as derivative from consciousness. Erwin Schrödinger, of the famous cat-in-a-box experiment, believed the universe was made of one single consciousness, expressing itself as a multiplicity of individuals. These were the minds that built the theory. They saw the math and its implications, and it led them to sound more like mystics than materialists. They felt that reducing observation to a mere mechanical interaction was missing the point, that the final link in the chain, the moment information becomes experience, had to involve a mind. And it's here that science, after centuries of separation, finds itself staring across a chasm at ancient philosophy. Specifically, at traditions like Advaita Vedanta, a school of Hindu philosophy. For thousands of years, these texts have described reality in a way that sounds eerily familiar. They speak of Brahman, the one universal consciousness that is the source and substance of everything. The entire physical universe, in this view, is Maya. Maya doesn't mean it's unreal. It means its reality is dependent and provisional. It's like a dream. The dream feels real while you're in it, but its existence is entirely dependent on the dreaming mind. Take away the dreamer, and the dream vanishes. The physical world, according to these traditions, is a projection within a universal mind. It only appears solid and separate because of the act of observation by individualized points of that same consciousness. Us. This is a radical claim, and for millennia it was pure metaphysics, until an experiment in 1990 made it look a lot more like physics. It's called the quantum eraser experiment, and it takes the observer effect to a new level of strangeness. The setup is a more complex version of the double-slit experiment. This time, scientists fire a photon at a special crystal. The crystal splits the photon into two entangled twins. They are linked. What happens to one instantly affects the other, no matter how far apart they are. One photon, let's call it the signal photon, goes on towards a double-slit setup and a detector screen. Its twin, the idler photon, travels a completely different path to a separate set of detectors. Here's the twist. The path of the idler photon is set up to record which slit information about its twin. Because they are entangled, measuring the idler photon's path tells you which slit the signal photon went through, even without a detector at the slits themselves. And just as you'd expect, when this which path information is available, the signal photon behaves like a particle. No interference pattern appears. But then, they added the eraser. This is the genius of the experiment. The idler photon, after its path is recorded, is sent to a device called a beam splitter. This device effectively erases the which path information. It scrambles the data so it's impossible to know which path the idler, and therefore its twin, originally took. The information is lost forever. When they erased the information from the idler photon, the interference pattern for the signal photon reappeared. Let me say that again. Erasing information about a particle's past changed its behavior in that past. The signal photon had already hit the screen. Its pattern was recorded. But whether it behaved as a particle or a wave depended on what happened later to its twin, in a different place. The choice to observe, or to erase that observation, reached back in time and determined the nature of reality that had already happened. This experiment challenges our deepest intuitions about cause and effect. It suggests that reality is not a fixed, objective thing that unfolds from past to future. It's a dynamic, shimmering web of possibilities that only solidifies into a definite history when information is registered. The line between a mechanical detector and a conscious choice to know or not to know gets blurry. The act of gaining knowledge about a system seems to be the critical ingredient that crystallizes reality from the mist. The universe doesn't seem to care about interactions, it cares about information. But the question remains, information for whom? Information doesn't exist in a vacuum. It requires a system that can interpret it. A sequence of ones and zeros on a hard drive is meaningless noise without a computer and an operator to read it. Could it be that the universe itself is a quantum computer, and consciousness is the operator, the one who looks at the screen and says, "Ah, that is a result"? The physicist John Archibald Wheeler, who coined the terms black hole and wormhole, proposed a radical idea called the participatory universe. He suggested that the universe, through the laws of quantum mechanics, requires a conscious observer to come into being. Imagine the universe's history as a giant game of 20 questions. A thing is brought into a room, and you have to guess what it is. Before you ask any questions, it could be anything. A car, a teacup, the color blue. It exists in a superposition of all possibilities. When you ask, is it bigger than a bread box, and get a yes, you haven't discovered a pre-existing fact. You have eliminated all the possibilities that are smaller than a bread box. With every question asked, every measurement made, you collapse the wave of potential and co-create a more defined reality. Wheeler argued that our observations, our questions, are what force the universe to choose a history from the infinite menu of possibilities. Without an observer, he said, the universe is just an unanswered question. This isn't a universally accepted view in physics. Far from it. Many physicists work their entire careers using the math of quantum mechanics, without ever touching these philosophical implications. The math works, the predictions are accurate, and that's enough. You can build a laser or a microchip without ever asking if reality is a dream. The counter-argument is robust. This is all just a misinterpretation of complex physics, anthropomorphizing a process that is fundamentally mindless and mechanical. And they may be right. This could all be a grand coincidence, a trick of language. But the parallel is stubborn. On one side, you have quantum physics showing a universe of pure potential that collapses into definite reality only when information is extracted. On the other, you have ancient wisdom traditions describing a universe of pure consciousness that projects a seemingly solid reality through the act of observation. Both point to the same unsettling conclusion: the world out there and the mind in here are deeply entangled. They are part of a single, indivisible system. We are taught to see ourselves as tiny, insignificant specks in a vast, cold, indifferent cosmos. We are biological machines that evolved on a random planet, briefly aware before blinking out of existence. That's the story of materialism. But what if that story is incomplete? What if we are not just observers of the universe, but the very mechanism by which the universe observes itself? What if we are the universe's way of becoming real? The chair still feels solid. The world still seems objective. But the deeper we look, the more it seems that the firm ground beneath our feet is a stage, and the script is written as we perform it. The evidence from our most rigorous science suggests that we are not separate from the world we see. We are participants in its ongoing creation. Every act of awareness, every moment of observation, is a vote cast for one reality out of an infinite sea of possibilities. The ballot box is open. It's been open this whole time.